Hello, AP Stat students. Last time you learned how to do a 4-step problem and calculate an interval. So we did a one sample Z interval for proportions. We will continue doing that, and we'll learn how to find how to choose the correct sample size. I'm going to show you the steps on a calculator, what to do for finding the confidence interval for a population proportion. And then another video, I will actually do a sample problem and lead you through the steps. But here are the steps. Step 1, you press stat. Okay. Then after that, you arrow across to the word tests. And then you arrow down to prompt A is what I have on my calculator. And that is called the one proportion Z interval. It's basically a one sample proportion Z interval. X will be the number of successes. N is your sample size. Your confidence level will be written as a proportion. So 95% confidence level would be 0.95. And then you hit enter to calculate. And when you hit enter, it will give you an interval in parentheses, your lower bound, comma, upper bound, along with your p hat and n. On the AP test, you will still need to show the formula with the numbers plugged in as quote work to get full credit on a free response question. This is just to help you check your work to see that you did it correctly. So this is a great tool to have. And if you look on your formula sheet, it kind of tells you how to go about finding a confidence interval without giving you everything. So since in this particular unit right now, we are talking about proportions, our statistic will be p hat. Our critical value will be z star. And our standard deviation of the statistic will be a variation of this formula. In this formula, you just need to know that we replace p with p hat. So use that formula. That's for the sample proportion. But instead of p, you're going to use p hat. So it kind of walks you through it without telling you everything. So you still need to know what p stands for, p hat stands for. So we'll do this in a separate video. Let's do an example just to bring back memories of how to do a one sample Z proportion. So according to an article in the San Gabriel Valley Tribune on February 13, 2003, most people are kissing the right way. That is, according to the study, the majority of couples tilt their heads to the right when kissing. In the study, a researcher observed a random sample of 124 couples kissing in various public places and found that 83 of them, so 83 out of 124, which is 66.9% of the couples tilted to the right. Construct and interpret a 95% confidence interval for the proportion of all couples who tilt their heads to the right when kissing. So we want to estimate the true proportion of all couples that tilt their head to the right when kissing with 95% confidence. Our plan is to use the one sample Z interval for proportions. Okay, for P. Check the conditions. So is this from a random sample? It's a random sample of 124 couples. Always refer back to the context of the problem. Does it meet the normal condition? So in this particular case, it's giving us value. So the number of successes is 83. So the number of successes is greater than or equal to 10. And the number of failures, so 124 minus 83, so that's 41, is also greater than or equal to 10. So the normal condition has been met. And as far as the independent condition, multiply your sample size by 10. It is reasonable to assume that there are more than 1,240 couples who kiss in public. Because you're not going to sample with replacement here. So you have to meet the 10% condition. So it's reasonable to assume that there are more than 1,240 couples who kiss in public. All right, so we know what p hat is, so we can go ahead and actually put that in our do portion. So before we do z star, let's put p hat somewhere over here. I'm going to just put it right here. So p hat, and it tells you what it is. It's 66.9%. I'm just going to write it as a proportion. That'd be 0.669. Okay, so we need p hat and we need z star, and we need the sample size to put in our formula to find the interval. So the z star, we are going to do inverse norm. And remember, that's area. So you have a 95% confidence interval. So you have a 5% left over, but you divide by 2 because you want left of the standard curve. So the area is going to be 0.25. Or I'm sorry, 0.025. So if you forgot, so 5% divided by 2, that's 2.5%. All right, and our mean is 0, standard deviation is 1, and you plug that in, you will get a z star value of 1.96. Okay, so we have our z star, we have our p hat. We can go ahead and plug everything into our formula. So our interval will be p hat, our statistic, plus or minus our test statistic. So that would be 1.96 or z star times our standard error. And our standard error will be 0.669 p hat times 1 minus p hat, and that would be 0.331 all over our sample size, which is 124. And then do all the wonderful math that we do, and I get 0.669 plus or minus. So I do all the stuff in the square root. I'll take the square root of it and then multiply it by 1.96, and I get 0.0828. And that'll give me an interval of, so I do 0.669 minus 0.0828, and that'll give me 0.586. And then I do 0.669 plus 0.0828, and I get 0.752. And so that's our interval. We are 95% confident that the interval from 0.586 to 0.752 captures the true proportion of couples that tilt their head to the right when kissing. Okay, for our last example, choosing a sample size. In planning a study, we may want to choose a sample size that allows us to estimate a population proportion within a certain margin of error. And remember, the margin of error is always equal to the test statistic times the standard deviation of our sample. So our standard error, that's what it's called, of our sample. So that gives us the margin of error. So this is how we calculate the margin of error. We take all that information. In order to find the sample size, the desired sample size, we want this desired margin of error to be greater than or equal to the margin of error you would get from our calculation portion. So, and here I do need to put that p hat is a guessed value based on a pilot study or past experience, or use 0.5 since the margin of error is largest at this value, so we have a conservative estimate. So if you don't know, you can always use 0.5 for p hat. Well, let's do an example. Suppose that you wanted to estimate p, the true proportion of students at your school that have a tattoo, with 95% confidence and a margin of error of no more than 0.10. Determine how many students should be surveyed to estimate that proportion within 0.10 with 95% confidence. So we have no previous knowledge of how many students have tattoos at our school. So that's basically what we're going to assume. So since we have no previous knowledge, we're going to use p hat as 0.5. Okay, oops. I don't know what happened. And then z star you can calculate by, well, we could just look at our information from above. We know at a 95% confidence level, the z star is going to be 1.96. Don't know what happened over there. Okay, so now we are going to plug in our information, our formula. So our desired margin of error is going to be 0.10, which has to be greater than or equal to our calculated one. So test statistic 1.96, that's our z star, times our p hat times 1 minus p hat, so 0.5 times 1 minus 0.5, all over our sample size, which we're trying to find. So we are trying to solve for n here. So the first thing we want to do, this is just solving an algebraic equation. We want to divide both sides by 1.96. And that gives me on the left side, and I'm going to try and use as many decimals as I can, 0.0510204,082 is greater than or equal to, that cancels, 0.25 over n in the square root. The next thing you want to do is you want to eliminate the square root. So you want to multiply both sides. You want to square both sides. And that gets rid of the radical. Squaring the left side will give us, and I kind of just, at this point, you don't have to worry too much about decimal places. So 0.0026 is greater than or equal to 0.25 over n because you eliminated the radical by squaring both sides. And now all I did was I cross multiplied. So I got 0.0026n is greater than or equal to 0.25. And our last step, divide both sides by 0.0026. And that gives me n is greater than or equal to 96.5. So go to the next integer that's going to be bigger than 96.5, and that would be 97 students. So we need to sample at least 97. We can't say 96 because that would make it less than or equal to, or less than. So we need to sample at least 97 students. However, you also need to make sure you can use that standard deviation formula. So make sure there are, to meet the 10% condition, that there are at least 970 students at your school. And those are your notes for 8.2b. Have a great day, AP Stat students.